Okay, so before we can look into solving quadratics by inverse operations, we first need to look at how to simplify radicals. So here we have the square root of 17. The square root symbol is the radical sign, and the number inside, 17, is the radicand. So, rules for rationalizing square roots. So, rationalizing is just the term we're going to use for simplifying a square root. Okay, so simplifying a radical. So, there's three things we have to make sure of. First thing, we want no perfect squares inside the root. Okay. I also want no fractions. And the last thing, I can't have any roots, so no roots in the denominator. Okay. So when we go to simplify a radical or simplify a square root, we need to make sure that our final answer has no perfect squares inside, no fractions inside, and no roots are left in the denominator. So we have a couple properties to help us make these things a little bit more simple. So we have the product property, product meaning multiplication. So if we had the square root of a times the square root of b, I multiply the insides. So I would have a times b inside. So an example, say I had the square root of 3 times the square root of 12. Now, looking at those two square roots, nothing really simplifies out all the way. But if I multiply the insides, I would have the square root of 36. Square root of 36 is a perfect square, right? So the square root of 36 would give me 6. Okay, now quotient property. We have the square root of a fraction, right? Quotient meaning division. I split up that fraction. So I would have the square root of a over the square root of b. So let's say I had the square root of 49 over 4. Again, can't really see what 49/4 would be or what that square root would even look like. But if we split it up, square root of 49 over the square root of 4, square root of 49 would be 7. Square root of 4 would be 2. Okay, so a lot of times breaking these things up helps us to see an answer more clearly. So now, let's look at the basic steps for rationalizing square roots. So, step 1, we want to factor or break down the number inside the radical as far as possible. Now, when I do this, I like to break it down by 2, 3s, or 5s as much as possible. Okay, it seems to make it a little bit easier. Then I want to circle all the pairs, so all the like numbers. Then I'm going to underline any leftover numbers that don't have any matching pairs. Then we simplify. Okay, and I simplify by pulling the circled numbers out, and then we're going to leave the underlined numbers under the radical inside the square root. Now, when we take out the circled numbers, right, we're taking out those pairs, you only take them out as one number. So if I look at the example that's up here, we circled the pair of 5s, right? So when I take that pairing out front, I only take it out as 1 5, because I have one group of 5s. Now, if I have multiple numbers that I take out, or multiple underlined numbers left inside, we're always going to multiply those numbers. All right? So, there are two ways you can go about simplifying. the first way is just breaking things down by 2s, 3s, 5s, as much as possible. So we'll do that way first. So 500. 500 breaks down into 2 times 250. 250 breaks down into 2 times 125. Now, 2 does not go into 125. So what I'm doing here, in case I'm doing this too fast, I took 500, and I no longer have the 500. I broke that down into 2 times 250. Then I broke down the 250 into 2 times 125. Now I'm going to break down the 125, but I can't do it by 2s. So I'm going to break this down by 5. So 125 is now going to become 5 times 25. And then I'm going to break down the 25 into 5 times 5. Okay. Now I'm going to go through and circle my pairs. So I have a group of 2, and I have a group of 5s. Now we underline the leftovers. So I have a 5 left over. So I'm going to take the group of 2 and the group of 5 out front. So I would have 1, 2, right? One group of 2s and one group of 5s. And again, we always multiply if there's multiple numbers. Then I have my square root, and the underlined term is left on the inside. So I have the 5. So my final answer, 2 times 5 would be 10 square root of 5. Now, the other way to do this is to look for perfect squares within your bigger number. So just to kind of show you an example of what I mean here, say I have the square root of 500. I know that 100 is a perfect square within 500, right? That would be the square root of 5 times 100. Now, with multiplication, I can break that up. I would have the square root of 5 times the square root of 100. And the square root of 100 is 10 root 5. Okay, so you can either break it down just by dividing, right? If you have a calculator, just divide by 2 until you can't, then try 3, then try 5. Or you can look for those perfect squares inside, okay? So there's 2 different ways you can do it. Alright, let's look at example B. Again, I'm going to start by breaking it down, and then I'll show the perfect square way. So 140. 140 is going to break down into 2 times 70. 70 is going to break down into 2 times 35. And then 35 is going to break down into 5 times 7. So, circle your pairs, right? I have one group of 2s, and then underline your leftovers. So, I'm going to take that one group of 2 out front, and I have the 5 and the 7 on the inside. Now again, when we have multiple numbers, we multiply. So my final answer, 2 square root of 35. Now again, if you wanted to do the perfect square way, I can see that I can take out a 4 out of 140, right? So if we had the square root of 140, that would be the square root of 4 times 35. Which would be the square root of 4 times the square root of 35. Square root of 4 is 2. Okay. Alright, C. Let's break it down. 360 becomes 2 times 180. 180 becomes 2 times 90. 90 becomes 2 times 45. 45 becomes 5 times 9. And then 9 becomes 3 times 3. So, I have a pair of 2s and a pair of 3s. Here are my leftovers, the 2 and the 5. So I would have one group of 2 and one group of 3's. So 2 times 3 would be on the outside. On the inside, I would have 2 times 5. So that would be 6 square root of 10. Now, some of you might have seen the perfect square inside of 360. If I had the square root of 360, we know that 36 is a perfect square. So I could break this down into 36 times 10. So that would be the square root of 36 times the square root of 10. Square root of 36 is 6. Square root of 10. Okay. Alright, last example here. Let's break it down. We have 2 times 240, 2 times 120. 120 becomes 2 times 60. 60 becomes 2 times 30. 30 becomes 2 times 15. And then 15 becomes 3 times 5. So this one has multiple groups of 2, right? I have one group of 2, two groups of 2, and then I have a 2, a 3, and a 5 left over. So this time I'm taking out 2 groups of 2. So I would have 2 times 2 on the outside. On the inside, I would have 2 times 3 times 5. So that would be 4 on the outside and 30 on the inside. Perfect square way. 16 times 3 would give me 48, right? So if it was 480, that would be 16 times 30. Sixteen's perfect square, right? So I would have the square root of 16 times the square root of 30. Square root of 16 is 4, and then I just have the square root of 30 left. All right, so the breaking it down way is a little bit easier for those of us who might have the strongest number sense, which is completely fine. That's the way I've always done it, right? Divide by 2, divide by 2, divide by 2. If I can't divide by 2, try 3, try 5. But for those of us who are a little bit stronger in our number sense and we can see how our numbers are created with perfect squares, if you can find the perfect square easily, you can do the perfect square method, right? Either way gets you to the same answer. All right, let's go on. So let's look at multiplying radicals, okay? So if you are given a radical multiplied by another radical, we want to multiply the numbers under one radical sign by multiplying them. Okay, well, yeah. So the example here, we have the square root of 50 times the square root of 7. So I put them all under one radical sign, and then I break them apart. Okay. So this example looks at the perfect square method, where they find the perfect squares in the numbers. So in this case, they found the perfect square 25. Okay. Now, the way I would recommend doing this, okay, it makes it a little bit easier because it's kind of uniform throughout the whole problem, for all the problems, is we're going to multiply everything first, okay? So the square root of 12 times the square root of 6, that would be the square root of 12 times 6, which would give me the square root of 72. Now I'm going to go through and break it down. Okay, so if you do the perfect square method, right, 72 would be 36 times 2. Okay? But breaking it down, 72 would become 2 times 36. 36 would become, and we can just say 6 times 6. Okay, so there's my group of 6. We're going to take that out front, and then the 2. So my answer here would be 6 square root of 2. Okay. So again, if you kept breaking down 36, right, you would have 2 times 18, 2 times 9, 3 times 3. So we would take a group of 2 out and a group of 3 out, which would give you the 6. Okay? Alright, another way you can do this, just to show you, for example B, is you can break everything apart first. So the square root of 6 would be the square root of 2 times 3. The square root of 15 would be 3 times 5. Now when I go to put everything under one root, it's already broken apart. So I would have the square root of 2 times 3 times 3 times 5. Some people like doing it this way because the numbers don't get as big on you. Now I can go through and circle my pairs and then underline my leftovers. So we're going to take the group of 3 out, and then on the inside I would have the 2 and the 5, which would give me 10. Okay. Looking at C, if we do the breakdown method, the square root of 3 would just be the square root of 3. Square root of 21 would be 3 times 7. So putting it all together, 3 times 3 times 7. Circle our pairs, underline our leftovers. So that's going to go out front. So we have 3 square root of 7. Alright, 14 is going to become the square root of 2 times 7. Square root of 2 we can't break down. Putting it all together, we would have the square root of 2 times the square root of 2, or 2 times 2 times 7, all under one square root. Circle your pairs, underline your leftovers. Pairs go out, and the leftovers stay in. Right, now the last thing we're going to look at is rationalizing a fraction. Okay, so this is a little bit tougher. So if you are given a radical in a fraction, let's pull the fraction apart and rewrite it as 2 separate radicals using the quotient property. Okay, so the square root of 25 over 3 becomes the square root of 25 over the square root of 3. Now, since one of our rules is we can't have a radical in the denominator, we have to rationalize the denominator. Okay, and how that looks. So we have the square root of 25 over the square root of 3. Simplify anything that you can. So I know that the square root of 25 is really 5. Okay, so I have 5 square root of 3. Now, to rationalize the denominator, I need to get that root out of the bottom and bring it up to the top. So the way I can do that is by multiplying the top and bottom by whatever is in the denominator. Okay, so I'm going to multiply top and bottom by the square root of 3. The reason why I do that is, now when I multiply, on top I would have 5 root 3. Okay, can't really do anything with that. But on the bottom, the square root of 3 times the square root of 3 gives me the square root of 9. And the square root of 9, as we know, is just 3. Now I don't have any fractions inside my radical sign, and I don't have any radicals in my denominator. Okay, so now this thing is rationalized as far as we can take it. So, looking at example A, start by splitting it up. Okay, so I have the square root of 49 on top, square root of 3 on the bottom. Now, simplify if you can. Square root of 49, that becomes 7. Now, I can't do anything with that square root of 3, so to get rid of it, I need to rationalize the denominator. So I'm going to multiply top and bottom by whatever's in that denominator. So on top, 7 root 3. On bottom, square root of 9. Now I just have to simplify the denominator. So 7 root 3 all over 3. Now, the big mistake people make is they see the 3 on top and the 3 on bottom, and they want to cancel those out. You can't do that, okay? The 3 on top has a root above it, so we can't cancel it out because there's no root in the denominator on that 3. Okay, so it's not the exact same, so we can't cross them out. All right. Now, b is simplified down for us already, and we just have to rationalize the denominator. So, I need to multiply top and bottom by square root of 2. So on top, we have 5 root 2. On bottom, we have the square root of 4, which would leave me with 5 root 2 on top and 2 on the bottom. Okay. Now, we're starting to get into some bigger numbers on top and bottom. So let's go ahead and split it. So we have the square root of 72 all over the square root of 7. Now, it would be a little bit tougher to do the multiplying here first. 72 times 7, that's quite a big number. So let's think about simplifying the radicals first, right? So let's look at breaking down the square root of 72. 72 is 2 times 36. And 36 is my perfect square. So I can take that out front as 6. Okay. Again, if you need to break it down by 2's and circle your pairs, you can do that, right? So on top, I now have 6 square root of 2. On bottom, I have the square root of 7. Now, rationalize. We're going to multiply top and bottom by root 7. Now, on bottom, I would have square root of 49. Now, this is important. On top, when I multiply, I'm only multiplying the radicals together. So the 2 and the 7. The 6 out front gets left alone. So 6 root 14. Now simplify if you can. The top 14, that's just 2 times 7. There's no pairs there, so that stays as 6 root 14. Denominator becomes 7. Alright. D, last one. This is the trickiest one. Okay, so we have the square root of 42 over the square root of 15. Now, we have two numbers that are able to be broken apart. Okay, 15 is 3 times 5. 42 has a bunch of numbers involved with it. Okay, so let's break apart everything we can as much as possible and see if something will cancel out to make things a little bit smaller and easier on us. So 42. 42 would be 2 times 21. 21 would become 3 times 7. So instead of the square root of 42, I have the square root of 2 times 3 times 7. 15. 15 breaks apart into the square root of 3 times 5. Now, because there's a square root on top and bottom, we can cancel some numbers out. Okay, so I see that I have a 3 on top and a 3 on bottom, and they're both under the square root sign. So those I can cancel out. Okay, so see the difference from example A to D, right? A, they didn't both have radical signs on top and bottom. D, they both have a radical sign, so I can cancel them out. So on top, I have the square root of 14. On bottom, I have the square root of 5. Now we just have to rationalize. So times root 5, top and bottom. So we would have the square root of 70 all over the square root of 25, which would become the square root of 70 over 5. Alright, so that is simplifying radicals. Now, next topic, or I guess next notes day, we're going to look at using this information to solve quadratics, because we can't always factor, right? Sometimes we're going to end up having to solve it using inverse operations, and to get rid of a square, we have to take the square root of both sides. So, that's that.